Hey everybody, this is Larry. This is day 28. Oh man, normally this would be the last day of the month, but it's a leap year. It's a crazy leap year. I don't know. Is it a crazy leap year? I don't know. All leap years are crazy, I guess, these days because it's always election year in America. But yeah, I mean, let me know if y'all are doing anything leapy. I should do something. I'm probably just gonna go to the gym to be honest. Leap day is leg day. Anyway, hope everyone's having a good day. Let's get started. Let's take a look. Today's problem is 513. Find bottom left tree right. Given the root of the binary tree, return the leftmost value on the last row of the tree. All right. I mean that could mean a few things. Oh, I guess, huh? Without the leftmost, I mean, I guess if it's just leftmost, it's easy. And it seems like I haven't done this before, which is actually kind of weird for a daily problem. So that's exciting. Okay, so basically you, I mean, I think a linear like traversal thing is pretty straightforward, but I'm curious if you can do better than that. I guess not, because the the answer can always be on like the biggest, like the longest step on like to the right side, anything, and there's no structure in this that we can take advantage of other than that is a tree. So I guess we just have to do it that way. My curious question is that like, I wish they kind of have an example where, like, in this case, the seven is on the other side of the five, so that leftmost is still like is it the thing that is like on the left side the most? I don't know. It's just I feel like they could add a couple of words. This is so late, like so terse. But all right, let's just do it that way, right? Then yeah, we could do a traverse, right? If no is none, then we just return. Otherwise, we actually want to keep the level because we want to keep the lowest level, right? So okay. So how do we want to do this, right? So one way to do it is doing it this way, and here we can have, like, if we do a pre-order or even in order, I guess as long as you don't do it in some funky way, even post order is probably fine. Yeah, as long as you do that, the post order, yeah, I guess post order makes the most sense maybe in terms of like fewer comparisons if you do it correctly. But in any case, what was I gonna say? Yeah, yes, that's it, right? Yeah, any traversal works as long as you go from the left first before the right first, and you don't have to worry about tiebreaker. So here we can say max level is equal to maybe 0 or even -1, just to kind of make it easier. And then do we return the node or the value? Okay, so the value, right? So leftmost is going to be, I don't know, just -1, right? Just doesn't have to be. Oh, I guess -1 is actually a thing on here, so let's just make it -infinity. I don't think it matters, though. But yeah. But then now we want to do traverse node dot left level +1, and this is just a regular, you know, post order traversal, right? So yeah. So if level is greater than max level, and this has to be a strict one because if it's the same, we would have already gotten it first from the left side. So yeah, so right, and here we need non-local max level, right, and max level is equal to level, and then leftmost is equal to node.value, and then we go to non-local. Do we just return the value? So it doesn't have to be unique, right? It doesn't seem to suggest that explicitly. But yeah, that's pretty much it, really, I think. Hopefully I didn't make a silly mistake, so let's give a YOLO submit. And that's pretty much it. Linear time, linear space. I mean, we do use not that much extra space, but we do need to use a stack, so that's gonna be O of H space or of N space. I guess you could do like one of those crazy Morris traversals or whatever it's called, if you really want to keep down the space, but I don't know, that's funky. But for now, that's all I have for this one. If you really want to look it up, Morris Traverso, then you can. I'll type it out. I don't know. I'm not a fan, to be honest. It just feels weird to manipulate input data in that way. Anyway, that's all I have for this one. Let me know what you think on this Tuesday, February, I guess 27th here, but I guess this problem is 28th. So I am going to do an extra problem, even though I haven't done this one before, but this is pretty straightforward. I don't know if I expect this on an interview. It feels a little bit too easy on an interview, but it could be like a warm up, a starter for an interview. So I don't know. Anyway, that's all I have for this one. Let me know what you think, and let's do one more problem afterwards. Stay good, stay healthy to good mental health. I'll see y'all later. Take care. Bye bye.